Next up, how could I write a program that could use the results of coin flip to pick dinner tonight? That is to say, how can we use the result of coin flip within our code? Currently, the results are just being printed to the user, so we can read that the result is heads or tails. But if our code needs to read this, then we have to do things a little bit differently. So for example, I could make a simple function called dinner. And this function will call coin flip and say if coin flip, we'll say of 0.75 is heads, then we'll print pizza. Otherwise, we'll print tacos. So now this function dinner takes the result of coin flip and determines should we eat pizza or tacos. What we're asking for is for coin flip here to have a value, right? So to put this perhaps a more clear way, I could say toss equals coin flip of 0.75, and we want to say, does the variable toss have the value heads? So is the thing that comes out of coin flip, is the result of coin flip, equal to this string? In order for this to work, our function needs to return a value. First, let's try this out and see if it works. So let's just scroll a little so we can see, and open our terminal again. Let's make sure we're calling our function before we try to run it. So we'll say dinner. Notice there's no parameters, so we don't include any arguments. Save our code and try to run it. So we'll say python functions.py. Now we still have our coin flips in here, so we have heads, tails, and tails, and then it said tacos. And if we run it again, it still says tacos, and again tacos, and again tacos. So it seems to be guaranteed to say tacos. So looking at our if statement, we're saying if toss is equal to heads, we'll print pizza, and in all other cases, we'll print tacos. So it's not necessarily that this is heads and then this is tails, because what if toss has some sort of different value? And in fact, let's find out what value toss has. So we'll say print toss. Comment out these coin flips. So now when I run our code, it says heads, none, and then tacos. So what's happening here? So we're starting from this function call here, dinner. Jumping up to the code in dinner, it says call coin flip with 0.75. So it's a 75% chance of heads. So we should usually get heads, which means we're expecting pizza to be the most common result. When we call coin flip, that says jump to the coin flip function. So up here, weight has a value of 0.75, and we execute the function. So the type of weight, because it's 0.75, is not an integer, so we go down to the next statement here, which says, is the type of weight a float? That is true, so we enter this branch, and it says, is it between 0 and 1? That's also true, so we enter this branch, and it says, generate a random number. If that's less than weight, print heads. And notice, it prints heads, so that means our code's working up to that point. But then the next thing it says is none. So once we've printed heads, our coin flip function's done. We return to where we called it from, and we say store the result in toss, and then print that result to the user. And that's when none is coming out. What that means is our function is not returning any value. So the value in toss is none. So none is a special value in Python. It just denotes the absence of a value. It's useful in situations like this where we're assigning something that doesn't have a value. Because this coin flip doesn't return anything, because it's just printing to the user as a side effect, the value of this function is considered empty or none. So to fix this, what we need to do is instead of printing our results to the user, we need to return those results to the calling program. The main difference here is instead of calling the function print, we'll just use the keyword return. Now with return, that's not a function, so we don't need brackets. You can include them, but they're more or less ignored. So we'll say return heads or return tails. So previously, because we were returning nothing, when we compared nothing to heads, that's false. So it comes down to our else and it prints out tacos. But now let's see what happens that we've fixed it to use returns. We will save and run. And now it says heads and then pizza. So walking through this again really quickly, if we have our function called dinner, we jump to the body of dinner. We call coin flip in the first line, which passes in a value of 0.75. Again, walking through all this, we have 0.75 goes into weight, which brings us to the float branch, which is a valid value. We generate a random number, and now instead of printing heads, we return heads. Notice we only have 2 values here instead of before when we had 3. So in this case, this print statement no longer occurs. The user doesn't see this at all. We return heads, which says go back to where you were called, which is here, and take with you this value heads. The value that's returned, in this case, gets stored in the variable toss. We then print the variable toss, and that's when we see what the coin flip was. If we remove this line, save and run our code again, then it just prints out the result of dinner. So we can run it a few times. Should be a 75% chance of pizza, so eventually it should change, unless we've done something wrong. There it is. Just very unlikely. So we got tacos. So we could try that again with different values to see if the percentages shift, but we've already tested our coin flip and believe it to be accurate. So again, there's a difference between the words print and return. Print is a function that has a side effect of displaying text to the user, typically through the terminal. Return is a keyword. It actually has 2 purposes. The first is to exit the function, and the second is to optionally bring with you a value. So we can say return heads. That value heads returns to where our function was called and gets stored in our variable so that we can use it in the calling program. Here's a somewhat simplified example to demonstrate the syntax of a return. So we define a function, in this case a function that adds 2 numbers a and b. In order to do that, we have to call that function with 2 values, in this case 10 and 20. So 10 goes into a, 20 goes into b. We run through the body of add, which just says add those 2 values using the standard operation, and then return the result. So 10 plus 20 gives us 30, so it says return 30. So then you can think of this whole function call as being replaced by its result. So we'd say sum equals 30, which is to say take the result of add and assign it to the variable sum. To do a return, we just have the keyword return, which means leave the function. And if you use return on its own without putting a value after it, it just does that. It returns out of the function, and it returns the value none, as we've seen. Optionally, we can include a value after the return word, which says, when you exit, bring with you this value, and this will be the value of the function call itself. Again, I'd like to emphasize the difference between the print function and the return statement. The print function displays values to the user. The return statement moves values around inside your program. As an example of this, let's go back to our functions demo, and let's make a few more functions here. I'll call one square, which takes in a variable x and returns x squared. Normally you wouldn't bother writing a function for something so simple that already has a built-in operator, but this is for demonstration purposes. Second, I'll have another function called square print. This will do the same thing, but instead of returning, we'll say print x squared. And lastly, I'll make a function for running these. I'll call it testing. Doesn't have any parameters and just calls the 2 functions. So we'll say s1 is the square of 10. Say s2 is the square print of 10. And then we'll just print them out. So we'll say s1 is s1 and s2 is s2. Oop, typoed square here. There we go. Save our code, scroll so we can see, bring up our terminal, clear it so we can see again, and run it. So we'll say, make sure we're running our function, testing, and now we'll say Python functions.py. And just to clean up our output a little, I'll make sure that's gone. So now we're only running one function, in this case, testing. Okay, so 2 things happened here. We called square and we called square print, and then we printed out the results. So walking through our code, it starts with the function call, right? It goes def, good. Let me say call testing. So we jump to the body of testing, and that says define a variable s1 as the result of calling square 10. So we take 10, we pass it into x, and then we run the body of square where x is 10. So 10 squared is 100. That says return the value of that, so return 100. That 100 gets stored in s1, and eventually we print it out. But before that happens, so notice nothing's happened so far as the user is concerned. We go down to the next line, which says square print 10. So it's the exact same thing except to a different function. So it passes in 10 to x, and that says take x and square it, so again 100. But then instead of returning that result, we print it. So we see 100 printed to the user. That function's done. We go back to where it was called from, and we say store the result in S2. But notice we didn't return anything. So what are we storing in the result? Well, when we print out the two values, we can see the first one stored the actual result, because S1 equals square 100. This was returning an actual value, so S1 has an actual value. On the other hand, when we said S2 equals square print, because this didn't return anything, this didn't have any value. So when we printed out S2, we get S2 has the value of none. And next up, to make sure we've understood all of this, let's do a code comprehension. This one looks pretty fun. It's got fun right in the name, so that's hopeful. So to walk through this code, we start at the first line as we always would. In this case, the first line says def fun. So define a function called fun that takes in a single parameter here. That says for y in range 0 to 4. So let's create a variable in our variable table called y, and we'll give it the first value in our range, which is 0. Just to make sure we don't lose track, we'll say our range is 0, 1, 2, and 3. So y gets the first value in the range and goes on to the next line. It says if y is less than 2. Well, 0 is less than 2, so that's true. We enter that branch. That says z, which is a new variable here, equals fun of y plus 1. That means we call the function fun with the value of 0 plus 1, which is 1. So this value 1 goes into the value x, and we run our function. So we create a new variable x, and we give it the current value, which is y plus 1, so 1. Now our function fun doesn't do much. It just says take that value and multiply it by 3, so 1 times 3 is 3, and then return that. So if it's returning, it goes back to where it was called from, and in this case we assign it to the variable z. So z gets the value 3. Next up it says print z, so we need an output section here. Do this here, output, and it prints the first value of z, which is 3. Now since we did this if branch, we ignore the else, we go back up, and y gets the next value from its range, so that becomes 1. Enter the loop. If y is less than 2, which it is again, then in that case we'll say z equals fun of y plus 1. So we call fun with y plus 1, so the variable x here gets the value 2. Fun function just says take x and multiply it by 3, so 2 times 3 is 6. That returns and gets stored in the variable z, so we store z has the value 6. We print the current value of z, so our output gets 6. And we restart our loop again. So we go back to the top and it says y is the next value, which is 2. Back into the body of the loop, it says is 2 less than 2? That's false. So we go down to the else branch here. And the first line of the else branch says z equals fun of y plus 1. Notice the plus here, though, is outside of the brackets, which means take the result of fun and add 1 to it. So pass y in as 2, so x gets the value 2. We jump up to the body of fun, which says x times 3, so 6. That returns back to where we were. We add 1 to that, so 7, and we store that result in z. So we say 7 gets put into z, and then we print the value of z. So coming into our output, we print out a 7. Back to the top of our loop, y gets the next value from the range. Put a space here, so we say 3. Noting this is the last value of our range, we enter the loop. Y is not less than 2, so we go down to the else, which says z equals fun of y plus 1. So we call fun again with y, which is currently 3. Fun says 3 times 3, so 9, and then return that. So then we return that back to where it was called from. So we now have 9 plus 1, so 10. We say z equals 10, and we store that in z. Cleaning our table as necessary. Next line says print the value of z, so we do that. We go back to the top of our loop. Our range is now done, so our loop is done, and that's all of our code.